Well, so from a physical point of view, what about the Leonard show? Well, we looked closely at the transmutation of chemical elements. Here you see that in addition to carbon atoms, which by the way are highly excited, you get C2. This is excited ion of carbon. So, well, once in the atmosphere, a nitrogen ion is produced, generated. Look, calcium, zinc, here's lithium, aluminum. Here, this lineup of elements, it was not present in our gun because everything was done before, so to speak. Polyethylene, so to speak, was initially given for analysis. Electrodes were given for analysis. Well, look, the resulting daughter products have high energies, reaching tens, even up to 100 electron volts. This is what I mentioned earlier, that if I divide 80 joules by the volume of this jet, here it is. Well, really, how much is the thickness, the length of it? If I separate it, it turns out to be 100 electron volts per, if you recalculate 1 milligram, how many particles are contained there? 100 electron volts per atom. So these are like canned goods with plasma explosives. And these spectra confirm that it is indeed in a highly excited state, and even materials, here the electrodes show copper one. But if I consider the entire spectrum, the ions are in the left area, 280, 230 nanometers. Well, and at the same time, we see that an X-ray spectrum is warming, which is emitted by this object. Well, and here are semi-resolved. So here should be, the lines of nitrogen, fluorine, and oxygen. Well, you can speak conditionally here. Sodium should be somewhere here. Silicon seems to be here. In any case, that's not what's important. What's important is that we see up to 175, almost up to 2. This kV, there's 2 kV radiation. So there, well, stay in the plasma of such radiation. If you do it without this hydrocarbon additive, there is none of that. If I just create a plasma focus, I don't have any of that.